Hello and welcome to Unmanned Uncovered, brought to you by Consortiq, here to help you take your drone program to new heights. I'm your host, Bryn Lucas, and this is the new and improved Unmanned Uncovered. No longer just a podcast. Oh no, there's real video as well. On this episode, joining me today, I have the Director of Aerospace at CGI UK Limited, Steve Vance, and he's here to talk about Spectrum, not just a really old computer. Oh no, Spectrum is crucial to what we do with our mobile phones and what we do with our drones and all the airspace above us as well. So Steve, thanks so much for joining us here on this episode of Unmanned Uncovered, the new and improved version where we get to see your real face.
It's great to be here. Thanks so much for inviting me.
It's an absolute pleasure. And I know this has been a kind of a conversation a long time in the making, really. We've had to delay it because of COVID and other things as well. But first of all, I think if you could give us a bit of an idea of who Steve Vance is.
Certainly. So I'm the Director of Aerospace in the UK for CGI UK Limited. CGI isn't just in the UK, we're a global organisation in 40 countries worldwide. We've got around 80,000 employees and we cover many sectors, but I'm in space, defence and intelligence. That's the business sector that aerospace sits within the UK. And we do many systems for clients, including delivery of global navigation systems, such as Galileo. We've also been delivering SATCOM systems. And we've also worked on many other complex systems that people ask us to do. They'd ask us to do the hard things well. That's really where we come in, safety and cyber related systems.
So how did you get involved in all of this then? What's your kind of entry into this world?
Well, I started off getting involved in navigation services. So I used to look after a large program of work which delivered highly accurate positioning services for the Galileo constellation. And I've also been involved in a piece of work called EGNOS, which it stands for the European Geostationary Overlay Service. It's the navigation signal, an augmentation of both GPS and Galileo, which aircraft use to fly in at great accuracy and at a level of assurance that can be used for safety of life. And so in areas where it's foggy or you haven't got an ILS system, which is a backup for global navigation systems, you can use that kind of EGNOS activity to go in and really in doing all this kind of work on navigation systems and communication systems, this has lent it very cleanly to the urban air mobility market, such as electronic vertical takeoff and landing devices, such as being deployed for vertical and Joby Aerospace. And also the non sort of air taxi. So when we're looking at drones, so CGI has been doing a number of things in this area. First of all, systems that effectively understand when the spectrum on which those systems rely for both communication and for navigation assurance are contested, and also trying to build backup systems for the more conventional communications and navigation systems, so that there's some resilience in the capability which those platforms rely on.
So I think for us with Unmanned Uncovered and with Consortiq and the drone industry, UAS as a whole really, but drones, I think to keep it simple, we're kind of looking at Spectrum and trying to work out what it is, because there'll be people watching this and listening to this that have never heard of Spectrum or may think they know what Spectrum is. So could you maybe in the simplistic terms, and then go into as much detail as you want to, just explain what Spectrum is to the masses?
Certainly. So Spectrum is the invisible utility on which so much of society relies. Whether it's the navigation signal that gives you your phone its direction on how to get from A to B, or the delivery of data to your mobile phone or your device, wirelessly, so that you can look at internet or receive data, and these sort of pervasive utilities that we rely on for navigation and communication, are just so integrated across every element of a society, and they're incredibly important for future air mobility sector. As we have a need to have what's known as electronic conspicuity, which is the understanding of exactly where every drone is or every eVTOL is, and exactly where it's navigating around the airspace, so that we can organize the airspace in a safe and efficient way. So as part of that activity, number one, you need to know where you are. So the way in which you do that is typically by global navigation satellite systems. So this is a network of satellites that orbits the Earth, and they distribute a message which an onboard computer compares against a number of different satellites, and based on the difference between that signal that comes from those satellites, it can work out exactly where you are. So then the next part comes in. So that's the first part of spectrum, understanding where you are using global navigation satellite system spectrum. So that signal that comes from outer space is a very quiet signal. It's effectively the sort of strength of a 60-watt light bulb. And so if there's anything that makes a similar noise to that signal coming from outer space, you can imagine the onboard receiver can not be able to hear that. And if you don't have navigation derived from global navigation satellite systems, you can't report where you are.
That's to do with recognizing, the signal being interrupted. So, for example, it can't say where my phone is because it's got too much interference between the signals going to it to recognize where I am.
Exactly. So if you have seen recently in Finland, there's been a large number of flights that have been disrupted on the eastern side of Finland, predominantly caused by military jammers that have been operated on the border with Finland. And what has happened is that flights effectively has been cancelled. I think Finnair had, in the order of about 20 flights cancelled recently, and more being cancelled at the time, because the onboard navigation systems rely completely on GNSS, so global navigation satellite systems, in order to safely approach the landing site and then land. And if they don't have that ability to be able to hear that signal from outer space, then they can't land safely. And so they're aborting flights. So there's, huge amount of cost going to Finnair with these aborted flights. And obviously, passengers, being in a dangerous situation because the flight can't land safely due to that interference, and then having to abort and go somewhere else. And if you try and translate that kind of impact to the electronic vertical takeoff and landing area, where those flights from Finnair, they're operating at a very high altitude all the time, and so they're not in the melee of the interference, which is typically at ground level. But as soon as you move to drones and you move to electronic vertical takeoff and landing devices, which are going to be at much lower altitudes, you can imagine the impact of flying through that kind of interference. And although that is focused predominantly at the issue has been occurring on the border on the east with Finland, this kind of interference isn't just the mainstay of the military. So there are many cities that experience a large amount of interference, mainly caused by people trying to prevent a onboard tracking device, typically used by fleet management services or companies that lease cars, to make sure that the vehicles are not being used in a way that is not aligned with the policies of that lease. And people use these jamming devices to prevent those GPS tracking devices from reporting their location. And these users, they don't realize the impact that they're having to the wider airspace. But the fact that these things can be bought legally in the UK, but they are illegal to use, means that they're really quite easy to get hold of and can impact the airspace in quite a bad way. And a number of UK city airports have had issues with ADS-B loss. ADS-B is the means by which aircraft are positioned outside the range of conventional radar, in case you don't know. So when those planes can't hear GNSS, they can't position, and so the ADS-B route where that plane is going is effectively lost. And again, general aviation hit this problem more frequently than higher aircraft, because they fly at lower altitudes, which is some sort of vision of what might be happening for eVTOLs. Yeah. But navigation isn't the only spectrum out there. So there's of course communication spectrum as well. So this is your 4G, 3G, 5G more in the future, and also satellite communication signals. So these signals can also be disrupted. They can be disrupted by, like GNSS, with jammers. But also these kind of spectrum, you need to understand the coverage very well, especially if you've got a safety of life application relying on 4G or 3G connectivity, to be able to receive high streaming video in the case of beyond visual line of sight drone operations, or to be able to maybe in the future have command and control that is completed autonomously. So you don't want a drone flying off doing a delivery and suddenly you need to say, hey, there's a big storm coming up ahead, I need my drone to go around it. And instead you can't communicate with your drone because you can't get that signal out to it. So having a good solid 3G, 4G and SATCOM, understanding is very important. And that spectrum can not only be affected by interference, similarly to what I was explaining a minute ago about navigation, but both navigation and SATCOM spectrum can also be impacted by obvious, sort of visibility to those satellites or to those terrestrial signals. So if you're flying in between a lot of buildings or you're flying down a valley, you can effectively lose visibility of the sources of where that spectrum is coming from. And so understanding the performance that you have, especially when you're flying in those more geospatially congested areas, is another element to consider in terms of spectrum quality, in addition to the interference that can emanate from ground sources such as the military or those more sort of lower power jammers that are being used to disguise personal location.
So you tug on this thread really of spectrum and the problems that surround anything that's going to be utilizing the airspace above us, and you pull on that little thread and it suddenly becomes a big woolly jumper that's all falling apart in your arms, because you touch upon one area and the knock-on effect is vast, isn't it? Because if you talk about aircraft with passengers on board and the issues they have with UAS, we're talking primarily about unmanned air systems. Drones is where we're going with this, like delivery services, there's inspection services, there's thermal imaging, there's LiDAR, there's all comes together under this one umbrella for UAS. But as we move forwards, I know there's urban air mobility, and again in the future that will be unmanned urban air mobility as well. But if we stick to the sort of the smaller craft that people have got, the Amazon delivery drones, for example, they're going to be operating in this space, which is so close to the ground almost that the interference is massive. And then I know that when we look at this problem, it's not just about not being able to fly around a storm so the drone might get impacted. It's also people using jammers to maybe intercept parcels, packages, whatever it happens to be being sent from point A to point B. So as a company like CGI that are working in this area, how many points of contention have you found? How many areas of disturbance have you found along the way?
Yeah, so CGI has been doing a piece of work for the UK called the GNSS Event Notification System. And this system is effectively a network of over 120 sensors across the UK, which are operated by the Ordnance Survey. So we take that data from those 120 stations and effectively process it and understand the volume of interference that is out there. Because the big question that was on everybody's lips previously is, okay, GNSS interference, we know it's out there, but really, how much is out there and how much does it actually impact the airspace? And so we received interference reports at every one of those stations, 120 across the whole of the UK, and to the tune of thousands of events over the period of the study, which was about 10 months. The actual impact on airspace would obviously vary depending on the strength of the device used, but we've also done analysis of ADS-B plots over the UK, and regularly in and around cities, ADS-B is just gone, because planes, when they're coming in at low altitudes, the amount of spectrum interference that's coming out is just so pervasive, especially in and around London, Birmingham, Leeds, these sort of major cities where there's a lot of activity, a lot of deliveries, a lot of lease vehicles, these kind of things that have these devices on board. And if we only to look at the sort of the size of the market that's expected out of here, I mean, it's 9.5 billion was an estimate of the global market, today, and it's due to grow, around about 60% year on year. So if we're really to enable this market cap, of expansion that's expected, there really needs to be a sort of means by which the UK can inform users at scale on when GNSS interference events are happening, just very similar to like storms. At the moment, you get a NOTAM, so a notice to airmen, out when there's a major cumulonimbus cloud, which can be hazardous to the operation of aircraft. What we do not currently do is, if there's a major GNSS interference event, which will take out a number of key safety related systems aboard an aircraft, we do not notify airmen as a result of an unplanned interference event. We do notify them of planned GNSS interference events. So the CAA currently does that for any military or other GNSS interference events that are happening, so that the airspace users are informed. But unplanned or unexpected interference events, nothing currently happens. And IATA last year, I believe, actually went on record saying that this is a serious safety related issue for current aviation, and that all air navigation service providers should understand the GNSS spectrum environment in the area they operate, and in the event of unplanned GNSS interference events, should notify airmen so that they're aware and so that they don't fly into these issues.
With drones, if we stick to the drone use, say in the future we're going to have parcels being delivered left, right and centre across the country, how can this work? Do we have to have planned air superhighways for drones to operate in? And is there a way of monitoring these say, we'll call them jammers, they're going to prevent these drones from being able to get from point A to point B?
Yeah, absolutely. So this network of sensors that we've got across the UK, this GNSS event notification system, this is one way in which future airspace used by these kind of devices could be monitored, and alerts be pulled out into UTM systems, so that not only conventional airspace, but also drones and eVTOLs could be notified and could be replanned around areas of interference if that was required for the safety case of their operation of their vehicle. The other sort of improvement that could happen is more resilient onboard navigation system. But this is a very difficult situation because the alternative navigation systems, such as inertials, such as positioning from systems such as 5G, we've got to make sure that the price point of those alternative navigation systems does not outstrip what is available from the market. And so what I see as the future is that you'll have a monitoring system for GNSS, and those vehicles, such as the lower quality drones, which are fully reliant on GNSS for their positioning, but they might have, SATCOM and 4G, available for their communications, effectively have a notification when such an event happens, so that they can reroute around this. And there, could be a network of sensors along key drone routes, so that effectively you knew that along the route that you were going to go, that there was a problem, and then people could be rerouted around those areas of interference until it was resolved. And that is another interesting issue, because trying to actually identify and police and control these kind of jamming events is going to be a major challenge for the UK. I mean, the first and most obvious thing is to change legislation so that it's not only illegal to use one of these devices, but it's also illegal to buy. If you get caught with one of these devices in South Africa, for example, you will get a jail term, and you will get a very hefty fine. on point, whether it's turned on or otherwise. You will just get it. You'll be in some very serious trouble with the police. So turning that legislation is absolutely the first thing that the UK should be doing. But also investing in monitoring infrastructure, so that those drone users can be informed. But then also having technology within the emergency services so that they can be identified when a new hotspot of interference is occurring that could, not only affect unmanned aerial vehicles, but of course it would also affect autonomous vehicles on the road in the future as well, so that they can effectively head out there with correct sensing equipment and be able to identify the exact location where it's happening there and then live in the car, and then pull the person over. And there are also the ability to integrate these kind of sensing infrastructure into CCTV, so that as soon as a vehicle drives past, you effectively snap them. So CGI have got a partnership with an organisation that enable that infrastructure to be put in place on roads. And then those combined of legislation empowering the emergency services and then roadside cameras, will hopefully enable this kind of activity that is a real strong barrier for future air mobility to be able to be attacked and prevented.
It's such a large area, isn't it, when we talk about spectrum and drones and UAS and then urban air mobility moving forward, and then talk about autonomous vehicles on the road as well. So it covers everything, and we don't really want to see another incident like we had in China in 2021, when during this incredible drone light show, about 200 drones just fell out the sky, and they claimed it was down to human error. Which may or may not be the case. But what I'm trying to say is it could happen again if jammers come into play where drones are up in the sky, couldn't it?
Yeah, certainly. So it's an interesting video, that one, because as you rightly say, it was a airborne drone display. So and there was a large number of people in between a number of tall buildings, and the drones were doing their display, and then what has been reported in a number of journals is that not a jammer, but a spoofer. So this is different from a jammer, which just ubiquitously just issues the same spectrum, is relied on by the drones for working out where they are. This spoofer effectively created spectrum which made them believe that they were somewhere they are not. And so what that did to the onboard systems of that drone display was to effectively convince the drone that it was within controlled airspace. So in the vicinity of a military base, or potentially an airport or something of that nature. And the onboard systems of that particular model of drone that was used in that display, when they receive a navigation signal which says that they're within an airport or within a military area, the immediate thing for that drone to do is to descend. And so en masse, tens of these drones effectively went straight vertically down onto the observing crowd below. As you can imagine, that caused quite a bit of panic. Thankfully, nobody was seriously hurt. But if we move then to look at that in an eVTOL or a drone, especially as we're talking about drones, transporting quite heavy packages, and also valuable packages as well. The ability to use a spoofing device, which can be, with the right know-how, it can be procured again off the open market. And there's currently, it's not illegal to buy that equipment, but of course it's illegal to use it. Same problem in the UK that we've got for jammers. Then there is the potential for somebody to create spectrum in the right environment to convince a drone to land, if the onboard systems do not have sufficient resilience in them to be able to understand, hang on, that's a strange signal that's coming, I should ignore that and just keep flying. So having the future drone platforms and eVTOL platforms tested ahead of operation to make sure that they are not vulnerable to those kind of, effectively what are cyber attacks, before they're issued for operation airspace is another thing that we should carefully look at, before authorizing drone and eVTOL platforms for use in our airspace.
Yeah, because it's that other aspect, the other aspect, isn't it? That, I don't know, I want to get some plectrums for my guitar, and so I order them from an online ordering company, and they deliver them via drone, and somebody out there decides that they want to intercept my plectrums for my guitar, and they put up their jammer, their signal, and the drone lands, and there they go. They've now got my 5 plectrums, and I can't play the guitar for a while. But that gives a very basic idea, but it can become really sinister. It can actually become expensive for people losing out on packages they're expecting, but actually it could become used for pretty sinister reasons eventually.
Yeah, exactly. And we just need to be very careful if we're ever doing any drone displays or flying drones in populated areas, that the vehicles that are used for those purposes are hardened from that kind of cyber attack.
I mean, it could go on forever, this conversation, but leave us, I think, with some things for us to think on further. What's the future going to be like for, if we kind of keep it to the more UAS drone aspect, but what's the future going to look like for us users, for what we're going to peer up into the sky and see?
Yeah, so if the forecasts, for the volume of increase in drones are realized, we are going to see, thousands of drones in the sky within, the next 5 years, and public perception of drone use is either going to enable this innovation and this efficiency and this realization of GDP, or it's going to terminate it in its tracks. And so making sure that we have the safety and the assurance of those platforms to not have incidents as this fledgling technology is getting off its feet is really something that needs to be baked into the future approach of future air mobility. So I expect that initially there will be point-to-point routes of drones whereby the airspace is very tightly controlled, and that the risk to society is very low. So it will probably be in very unpopulated areas where we see large amounts of drone traffic. But as those individual point-to-point routes are effectively proved, and the safety case and the systems confirm that they're operating safely, then I fully foresee additional routes being opened up and more traffic being routed along those areas. So it's a really exciting time, to be here right at the beginning of a journey. I feel a little bit like those people when the first airports were being put in place. Now we're talking about the first drone ports being put in place only down in Coventry the other week, for those of you that went. So it's a really exciting time, and I really hope that we can grasp these nettles and really bake the safety in to the systems that enable this to excel as much as I and much of the industry hopes.
What about the user, the drone pilot? Are they going to have to learn different processes, or is it going to be pretty much the same for them?
I think it's going to be pretty much the same for them from a drone pilot perspective. Already, a number of the commercially available drones do have GNSS checks within them before they fly, but they can hit those kind of problems in mid-flight when their drone is high up. So trying to safely get out of that situation isn't as safe as it could be. But having new feeds of information into the drone pilot, so that they are aware of the interference event before it happens, or they can pilot around it in the case of BVLOS, beyond visual line of sight drone operations, but also having drone platforms, or looking for drone platforms that have resilient communication and navigation services inbuilt into them, and looking out for those. So, so CGI, for example, are building a 5G GNSS fused system in a chip with a chip manufacturer, so that then as you approach lower altitudes and you've got 5G available, you can effectively position from 5G masts as a cheap and effective backup for GNSS. So, looking for those kind of, resilient positioning and navigation systems in your drone as a drone pilot is something that they perhaps should look out for.
Thank goodness there are people far smarter than me that are looking after the futures of our skies. Is there anything you'd like to finish off with, Steve? Anything you'd like to add?
No, just, I always feel a little bit like a doom and gloom person when I'm talking about safety. It's not that, I don't want this technology to take off. I think it's got phenomenal applications in so many areas, from emergency services, search and rescue, improving the efficiency of our renewables, out to sea, delivery, remote inspections for buildings. It just goes on and on and on, and it's such an exciting area. And when that's just drones. You look at eVTOLs. If you've seen the presentations by Joby and Vertical and other eVTOL manufacturers, the thought that in the future I could order a taxi from my mobile phone and that would automatically have a vehicle turn up on my doorstep, take me to a local aerodrome, that would fly me to an airport, and I would have a journey end to end seamlessly from my door to door. I imagine that possibility in the future. It's just such an exciting time to be involved in, and I really hope we can get this really off the ground.
Yeah, and that future doesn't seem like it's too far away either.
No, indeed.
Steve, thank you so much for chatting to us.
Thanks so much, Bryn. It's been an honour to be on the podcast.
Well, there you go. Thanks very much to Steve Vance for being the first guest on the new and improved version of Unmanned Uncovered. New and improved because it features real people and their real life faces as well. Hopefully you found this episode both enjoyable and informative. And don't forget to check out Consortiq, here to help you take your drone program to new heights. We'll see you next time.